Okay. Can you guys go to chapter 3, please? If you don't mind. Thank you. Thank you. Thank you. Thank you. Chapter 3. Chapter 3 talks about commercial load calculation. So exactly what we have been doing, guys. So what I'm going to do, highlight a few things. Determine minimum lighting load. Remember, guys, the lighting load that you did? The 3.5 volt amp per square foot for the building. That's exactly what we did. And receptacle load. Can I emphasize the word minimum? When you guys do load calculation, everything that you calculate is minimum. Can I, if the panel size, Karen, is 100 amp, can I put a 200 amp panel? Yes. Why wouldn't we put a 200 amp where we need 100 amp? Because we don't want to spend more than what we need to, right? Because an optimum design, guys, is a balance between quality design and an expense. That's how you come up with an optimum design. Determine the minimum equipment load. So does that sound familiar? Here's light, here's receptacle, here's equipment. Determine reasonable connected load. So then you have to compare it with the actual connected load and tabulate the unbalanced load. How to put it, the unbalanced load so you can size your neutral. Exactly what we guys did. When we have, the second thing you have to pay attention when you do load calculation is something called continuous load, guys. You remember what we did direct with the continuous load? We multiplied by 1.25, like all your lights. Non-coincidental load. What did we say, guys, between the heat and the cool in a building? We said these highly unlikely they're going to be all at the same time. So what do you do with them? You basically choose the largest of the heat or cool. All the calculation, guys, is based on the secret book. Growth, future growth. I will remind you guys, in our project, we had a 5,000 square foot future growth, right? We added this one. We also have a future condenser. You guys remember that? So that's, you have to always accommodate for future growth. If you don't have the equipment to accommodate for this one, it's a good idea to put 10 to 15% over on your system for future growth. Provide future, again, you're going to put the future growth above and beyond the minimum requirement, good practice and efficiency, consultant engineer, guys. So if the code says what we do most of the time is a good design, like I said, an optimum design is trying to find the balance between too much and too little, right? You need a good design at an affordable price. That's always the balance. So if the NEC code book, guys, we typically go higher than NEC code book because that's what the bare minimum. NEC is the bare minimum. Okay, steps is to determine the load that the electrical system is to serve. You have to find all the loads that's going to be fed, and the loads will be receptacles, light, and mechanical equipment. Then you need, from there, you can go size your feeders and your servers. And later on, you will be sizing your branch circuit. NEC guys give you a minimum load requirement for lights and receptacles in a commercial building. And all the calculation that we're going to be using, it's going to be based on the NEC code book. And I refer you to the Excel sheet that I walked you guys step by step with all these calculations. Energy code. Now that's not that. Did we say about anything about energy code? There is a complete. Here's what happens, guys, between energy code. Energy code will require you to use much smaller load than what the NEC code book allow you, force you to use. So be aware of that one. And promote the use because we need to energy efficiency. For example, volt amp for light will be 3.5 volt amp per foot. This is the NEC code book, NEC, and based on the location, energy, this is NEC, energy code can get you a watt, which is almost equivalent to a volt amp, right? Almost equivalent to a volt amp of one volt amp, or let me say just 1 volt amp per foot. So the NEC code book annum is asking you to size 3.5 more on average, 3.5 more than what the code, the energy code, allow you to do. Here's the good news, Derek. The good news in 2014, you know what they did in 2014? They allow you to size your equipment based on the energy code. So This will be a major change in 2014. You are allowed to size your equipment based on the energy code if you have a way of monitoring your loads as a building automation system. That's a major thing. So be aware of this one, guys. 212, you guys have been, and 220.12 gives you the volt ampere square foot for general lighting, and we said 3.5 volt ampere square foot for the commercial building. If you have a window lights, show window lights, you guys did that one. We have a 200 volt ampere linear feet, and you guys have an item on your list that did the calculation Excel sheet from 220.14G. Track lights, you guys remember the word track lights that you did? 150 volt amp for every 2 feet. This is where it's coming from. I'm going fast over these, Derek, because guess what? You guys have done it. You have it in the sheet. You should have built it in your sheet. 1 receptacles installed above each 12 sections. So for this will go into the track lights. Here's where the track lights for every 12 feet section, what they do is we'll have 1 receptacles too, so you can plug that system. Equal greater than the allowances. Not required to have connected load be equivalent required sufficient capacity. So you have to have enough capacity for these loads. We'll move into that one. Nonlinear load. Nonlinear load, guys, the loads that have electronic equipment, these guys are the most offenders when it comes to the neutral. So if you have a nonlinear load, you always count the almost we pull a full neutral for lights and receptacle. 3 volt per square foot, or so we have a 3 volt per square foot depending where you go for the minimum lighting. We talked about this one. Then you have to also have the connected load, and you're going to choose the largest. Values become the greater of the two. So you're going to use the connected, like I told you guys, you're going to take the volt amp of your fixture and the 3.5 volt amp of your general light from any secret book and choose the largest. For the storage area, the code allows you 0.25 of a volt ampere square foot. I'm sorry, 3 volt ampere square meter, 0.25 volt ampere square foot for your storage area from the table. For show window, we talked about the show window, guys. For that particular area, you have 200 volt amp per linear foot. So you take the feet, multiply it by 200. Receptacle outlets, all your receptacle outlets will be counted as 180 volt amp based on this. So multiply this one by the number of your receptacle. Then you have to receptacle for AC equipment. The same thing if an AC equipment 180 volt amp, and then you have to derate them. Here's how they do the receptacles, Karen. If you have 1 receptacle, it's counted at 180. 2 or duplicate receptacle 180. If you have a quad receptacle, they have each one of them is 180 here and 180 here. If you have a quad also, so these will be 180, these will be 180, 180, 180. So when you guys calculating, Brian, when you start laying out your receptacles in the floor and you have a quad, the quad will count as what? 360, 280, 180. Just be aware of that one. Area is considered to be damp or wet location. When you put your fixture, guys, or receptacles or anything in this here, right underneath the canopy here, this will be a damp location. Obviously, if it's right in this area, that's your wet location. Who cares? When you put your receptacle there, they have to be in an enclosure rated for wet location, in-use cover, and they have to be weather resistant, and they have to be GFCI. Sign outlet, we assign based on this, guys. You have to allocate a 1200 volt amp for every commercial building, a 20 amp circuit dedicated to the sign that says welcome to Dunwoody as you walk into the main door. If you have more signs, you allocate more 20 amp circuits to it. So at least, that's what you guys, when I say sign, remember when we, on our calculation, we said sign, that's a sign that says going to say welcome to Holberg. We assign 1200 volt amp for it. Now, The rest of them, guys, the motors, you guys remember how we did the motors? We took the first largest motor multiplied by 1.25 plus all the other motors. Appliances, you add them nameplate and you derate if they are kitchen appliances. HVAC equipment, you add them at 100% if they're heating, and if they are cooling equipment, you add 25% on the largest. So all these, and you choose the largest of the two. Hermetic motor compressor, that comes, guys, with the HVAC equipment. You know, you have the motor, you have the evaporator, the condenser, the voltage. All these information have to be provided for your HVAC, your cooling equipment. So all these will be converted into volt amps as you put the value into your system. The good news for us, guys, the condensing unit. You guys remember the condensing unit that I gave you? It has a full load amp. We use that full load amp for the condensing unit. Multiply by the voltage by 1.73, and that will get you the allowances of volt amp for this particular piece of equipment. This is just giving you an example of how do you calculate an AC unit. Here's an air conditioning line connected with a split system. You go to the condenser. Can you guys see it? Single phase. You multiply the amps times the voltage to get the info about the condenser, and then the motor compressor. It's a three-phase, then you multiply the amps by the voltage by 1.73, and then you add them up, and that will get you basically the volt amp for the cooling. And here's my evaporator. That's a split. That's the evaporator. It's a split system. Same thing, guys. This is it's a 13.5 kW, and for the evaporator, here's information about your evaporator, full load amps. You can calculate all this information, the outside unit and the inside unit, add them up together, and that will get you the full load current of your HVAC equipment. Remember, if it's heat and cool, you choose the largest of the heat or the cool. You choose the largest of the heat and the cool, for the cool. This is just going through the information, guys, about different places, how they find the load allowances, connected load. Okay, this is interesting. For the general lighting, the drugstore, guys, the connected load was this amount. Then you see allowed this amount. So you are to choose, allowances is used. So you have to choose the largest of these two values, 4185 and 4155. I can't emphasize, when it comes to light, you have to choose the largest of the code or the actual system that you designed. Look at this. In the storage area, I have a connected of 927 and a volt amp of 250, so the connected will rule. The connected will rule. You don't use the code, you use the connected. Now, and you guys, in your Excel sheet, Adam, you built this one into it. You have a value and you choose the largest of the two. Talked about adding all this equipment. I'm going to go directly into, that's basically it. I'm going to show you a couple of calculations that they did, guys. We talked about these ones and how you allocate them. Talked about this. I have some, talked about how to calculate HVAC equipment. Make sure you, here's your HVAC equipment, guys. You'll get compressor. For example, here's my compressor rated load amps. Compressor rated load amp, and you get the voltage. Here's my voltage. Let's just say my voltage is 2.8, and it's single phase. That's a condenser, single phase condenser. Here's the horsepower of it. Here's the full load amp. You can find the information for the condenser. Maximum fuse, minimum branch circuit selection current is this amount. Here's the fuse. So when you find the full load current for this piece of equipment, since it's what you take is you take the 17.6 and you multiply this one by 208 and multiply it by 1.73, divide by 1,000. This will be for the compressor. And then for the condenser, what you do is you take the 208 and multiply it by full load amp is 2.5, and it's single phase. And then you add the two. That's how they calculate them. In our example, guys, we give you a condenser, and I give you the full load amp of that condenser, so you don't have to do them separate. But if they were separate, that's how you calculate them.
You can divide that by 1 by 1,000.
Yeah, thank you. 1,000. Yep. So you can get the kVA, but you don't multiply by 1.73 because it's a single phase. Good point. Okay, so that's basically how to calculate. So operating voltage, this is my compressor, not electrolyzer, evaporator motor, and a heat strip in it too. You have to accommodate for these. So also you add these one exactly like you did at the top, and you add the kVA to it of the heater. You guys have used this table. This is 220.12, and I'm going to emphasize one little thing in that table. One little thing is office building. For office building, you guys, with your friend Chad, we have been using a 3.5 volt amp per square foot, right? Or the connected load, whichever is larger, or the connected load, whichever is larger. Warehouse storage, can you guys see when they were talking about warehouse storage, they're allocating 1/4 of a volt amp. What do you do in a storage area? You don't need to do a whole lot of things. In an office building, you need to do work, right? You sit there and working on equipment, on things, so you need more light. You can see how much light they allocate for different areas. Courtrooms, for example, if you're doing a courtroom, they're allocating a 2 volt amp. School, you need to do your work, like here, you're allocating a 3 volt amp and so forth. Any comments, guys? Any questions? I want to remind you the energy code, Derek, will give you substantially smaller values than this, and you can size based on this. So if I size my lighting load, guys, for the office building, and I came up with 200 amp panel, that's based on NEC, right? If I use energy code, ASHRAE, and I could come up with 100 amp. Right now, you have to use the 200. In 2014, just coming, in 2014 NEC code book, they will allow you to use the 100 amp. So it's catching up. The NEC code book is catching up with the energy code. This is a major change, believe it or not. You always, as engineers, we always guys use our judgment too. But now at least the NEC code book is acknowledging that judgment. Okay, here's the fixture that they use for this particular project, which you guys will be doing with your friend Chad, right? Okay, it doesn't want to work now. Let me just go over one calculation for the volt amp continuous load. Okay, so this is how they schedule. Let's just zoom a little bit here and see. Okay, they have a style I, fixture I. It's 61 volt amp coming from manufacturer. There's 27 of them. So you took, I think this continuous load, I think this is 27 multiplied by 61. Is that what would that give? I think. 61 volt amp, right? Can you do the math? Somebody do the math. So that's where you volt amp, and it is under continuous, 1.25. And then the same thing, guys. We have 86 here multiplied by 2. That's gotta be it. And then 26 here multiplied by 3, and get you all these values. They're all continuous. They have a style E, the emergency. It's a 20 volt amp, and it's non-continuous. The only one light that they have, guys, that's not continuous load is the emergency light. And guess what? The emergency light, actually, we don't count them when it comes to the load. Do you know why we don't count the emergency light? Because the emergency light, are they normally on? They're on when the system is down. So they don't contribute to the load on your system unless you're using a fixture that work dual duty, emergency and normal lighting fixture, which they do. These bug eyes, for example, Derek, when to start with, they don't take a whole lot, like 30 watt. But do we count them? No. Why? Because they're not on. They're only on when what? When the system is down. So they're not going to add anything to your feeders. Not a whole lot of load to your feeder. Adam, they are the same value. Okay, so that's for your lights. Same thing, guys. All these calculations. Then you add the total volt amp for each for the light. I want to just spend some time to show you guys how they did the load calculation for this project here. They're doing for the drugstore a load calc. And I know you guys are sick of doing load calc with Chad. I did the Excel sheet with you, and I did it by hand. I want you guys just to pay a little bit of attention to the way this author is doing it. So look what they did. 220.12 connected load from table 3. So the connected load, they have 3 volt. This is my connected load. So NEC load and connected load. This is coming from the actual. This is multiplied this by this. That will get you the NEC code. Look, 3 volt amp. This is the square foot multiplied by 3. That will get you this value. And then you're going to add them up. Can you guys see how they went down here? And you are supposed to choose their continuous load, both of them are continuous load, and you're supposed to choose the largest. Can you guys see there? The neutral will see all of them, and both continuous load. You choose the largest of the two. Can you guys see what they did? They put the two next to each other and picked the largest. That's what they did. And they're continuous load. Storage area, the same thing, guys. They picked the largest of the two. The connected happened to be the largest. And they also put them under a neutral. They're doing a neutral calculation and phase calculation, exactly like we did. Exactly. This is a load calc, basically. Moving all the way, guys, into receptacles. Here's my receptacle outlet, 21 of them, 180. Came up with this, right? Copy machine, all of these receptacles, they're adding them all up, and they are non-continuous. They will be seen by the neutral. Anybody knows why they did not derate the receptacles? You only derate the receptacle if you have what? If you have 10K or more. Are they 10K here? No, they're like less than 4K here. They don't derate them. Then they added all these receptacle, cash register, blah blah blah, heater, and what's not. They added them, and if they're continuous, they put them under continuous, so they can multiply them by 1.25. If they're non-continuous, they put them on the non-continuous, and they also added them. If they are single phase, they added them to the neutral, so they can calculate the neutral. So that's basically what we did. I'm going to go all the way to the last one here, and see how the AC equipment. They did the AC equipment. You guys have done that with me, so I'm not too worried about that. So here's my AC unit. I have 42.5, 360 volt. Here's the volt amp. Here's my volt amp. The neutral will be 0 because that's a 3-phase. The exhaust fans, 2 of them at 120. Here's the total, continuous. And then you add feeder load 25% for continuous. They added 25 for continuous plus 100% for non-continuous. And that will be the total load for the phase and the total load for the neutral. And then they divide this one by the voltage, and it will get you that neutral, the 3-phase size, as well as the neutral size in terms of amps. Any comments, guys? Any questions? That's exactly, Adam, what you have done with your friend Chad. The same method. Slightly different arrangement. So they did the load calculation exactly what we did. Can I have a thumbs up, Chad? We fully understand how to do that, kinda? Almost. How about Brian? Cool. Karen? So please do yourself and myself a favor. Can you guys just go over them, read that one time? You know, this, you're going to live with this all your life. So here's, when you look, you can see, wow, they did it slightly different. Because the nice thing about these, Brian, all these are different examples. Like, for example, I did not have a copy machine in my area, receptacle, cash register. So here's how you do it if you have a cash register. Can you guys see that? So that's what gives you a different example. I have cash register, and I have 2 of them. The volt amp 240, get them at 480, and they're assuming them to be continuous. They're assuming them to be continuous because they're electric doors. They added them here. So another example of load calculation. Another example of load calculation. I think that's all I have for you, ladies and gentlemen. Any comments, guys? Any questions about these short little chapters? Any comments, any questions? Next week, guys, I'll do chapter 4 that talks about branch circuits. I need you to have undivided attention when we do branch circuits. So how do you branch circuits in a commercial building? For receptacles on light and equipment. I have a really good one for that. One more time. Any comments, any questions? Would you guys be able to print for your chat today? Load calc? We'll try. What I would like to do, guys, today is just walk around, if you don't mind, and look at where you are in Excel and see where how your Excel sheet is going. Thank you.